Namaskar दोस्तों, welcome to channel Toxicology on board. Today in this video we'll discuss some of the around three questions we'll be discussing from ABT recertification question paper year 2009. Questions will be related to respiratory toxicology, respiratory system, inhalation toxicology. So first question taken from year 2009 ABT recertification question. Okay. Question is which of the following lung toxicants affect primarily the periphery of the lung, resulting in restrictive type of lung disorder. So you have to understand whenever we are reading inhalation toxicology, respiratory system, no, as a target organ toxicity, few things are there towards the end of the slide. Also, video also I'll be discussing. Here, one thing you have to remember is particle size. Particle size, whatever the aerosol or dust particle, vapor, we should know the particle size based on the particle size only and based on the type of movement of that particle, whether it is diffusion, impaction, sedimentation. So that and which region of the respiratory tract it is going and depositing or penetrating that you have to remember. So most of the questions will be revolving around this area only. So now this question is this we have to identify two options from this particular given options. We have to identify where this particular chemical will go and they will deposit in the periphery of the lung, resulting in restricted type of lung disorder. So right answer will be in the green text, that is iron oxides as well as coal dust. So these are the things, lung toxicants. They'll primarily they will affect the periphery of the lung and they will result in restrictive type of lung disorder. So how this coal dust as well as iron oxide as a toxicant, what kind of occupational diseases it is causing, that we'll see. For this you have to read lesson 9th edition, page number 821. In this you have to please we have to read table 15.7. Here I have only incorporated in this particular slide only coal dust and iron oxides. I would request you in this table 15.7 around more than 20 plus chemicals toxicants they have given, like sulfur dioxide is there, various other type of things are there, ammonia, chlorine, sulfur dioxide they have listed, and they are causing which type of disease. Beryllium, some metal diseases also they have given, like sugarcane dust, berylliosis, like that also. And so read this one, but in this slide only we'll discuss coal dust and iron oxide. So coal dust is causing the type of the occupational disease. If a person, if there is a factory worker and is working with the in a coal mining factory or coal refinery, like that. Repeatedly on a daily basis, this worker is exposed to this coal particle or coal dust. So the type of occupational hazard it will cause is coal workers pneumoconiosis. So this is a very well-known occupational lung disease which is caused by this coal workers. So here you can see how it is going to affect the lung, which particular part. So industry exposure is through coal mining, and the chronic effects, acute effects, more than acute effects, this particular coal dust is going on upon repetitive administration for a couple of months or years. It is causing fibrosis as well as emphysema of the lung. Okay. Next is iron oxide. Iron oxide, you have to, whenever it comes to iron, think about the states also. Oxidation state, Fe plus 2, Fe plus 3, all those things also you have to keep in mind and read. So, with respect to iron oxide, so the disease which is causing it is called siderotic lung disease. I think one of the Latin name or chemical name something is with respect to iron, it is called siderosis. That is the reason iron Fe, ferrum it is ferrous it is called. But I think uh, some Latin or some origin is there because of which this term will come, siderotic siderosis. That's why the disease is called siderotic lung disease or silver finisher lung or hematite. Since it is related to iron, hematite miners lung or welder's lung. So the type of the workers who are working in welding, steel industry, some people who are manufacturing, workers involved in the jewelry manufacturing, foundry work, hematite mining, all these workers, they are prone to get this type of siderotic lung disease. Okay, and if you see the acute, upon acute exposure, this iron oxides will cause cough, and upon repetitive or chronic exposure, they will cause silver finishers lung with subpleural and perivascular macrophage aggregates. So this is how you have to understand, means in the, if you look into respiratory system, different branches will be there, alveolar macrophages. So like that, it is going to affect your subpleural as well as perivascular macrophage aggregates. Hematite manner lung disease, if you see, with diffuse fibrosis like pneumoconiosis, like in the case of coal, dust, how it is causing pneumoconiosis. Similarly, this hematite minus lung, the characteristic feature is pneumoconiosis. Welder's lung disease with bronchitis. So here you can see siderotic lung disease. Okay, so pause the video, go through the pictures also to understand and to memorize. We'll see next question. Next question is also taken from ABT recertification question, that is year 2009. The question is with respect to something related to the nature of the exposure, that is the chemical which you are getting exposed, no, of the nature, like physicochemical properties is involved, like solubility here. So we'll see the question. The question is the most important factor in determining the amount of inhaled gas or vapor which reaches the lower respiratory tract. As I told you, whenever you're discussing about inhalation toxicology or respiratory system, in which part of the region of respiratory tract it is going and binding or depositing, this is very important. So the lower respiratory tract, so what is the characteristic feature means that particular amount of inhaled gas or vapor, it's water solubility. So right answer will be the green text, that is water solubility. So the explanation which is given by the previous ABT students, toxicologist, is that less water soluble. So whenever a certain chemical to which we are exposed, if it is less water soluble, then there's a deeper lung penetration. Okay, this is a thing that you have to remember. So where you can read means, see, there are certain students who can go back and read in Clayson the 9th edition respiratory tract, and if somebody cannot be able to read complete 1500 pages of textbook, you can also read Clayson short textbook in the page number 224 under chapter 15 toxic responses of respiratory tract only. This particular point you see. Second point, key points. Certain times no, it is very difficult for us to remember everything, so at least in the textbook, no, try to read keynotes, or some diagrams will be there, so tables will be there, so don't forget. If you can't remember every passage from the particular chapter, at least try to remember the keynotes, try to remember the tables. So I have taken from the keynotes. I am giving you an option how to read, so that, see, we might read hundreds of pages. If you don't remember at the time of exam, that is no there is no point. Okay, so second point, if you see, water solubility is a decisive factor in determining how deeply a given gas penetrates into the lung. So this is the key learning that we have to remember. So in addition to solubility, I would also, as I am saying, no, think about, read about particle size. Particle size is usually the critical factor that determines the region of the respiratory tract in which a particle or aerosol will be deposited. In my channel also, repeatedly some of the questions from previous years, maybe from the year 2000, 2000 or 2001 to 3, I have given inhalation toxicology particle size. So those videos I'll give in the description in the link. So please check and pause here. Try to read about other things like asthma, emphysema. Okay. Now we'll go into third question. And as I told you, please try to remember the respiratory tract, which particular region is responsible for the deposition of which particle size. Okay. Now we'll see question number 3. Question number 3 is also taken from ABT recertification question paper, that is year 2009. So which of the following is a correct about inhalation toxicity testing? So we need to identify out of all the options which is applicable to inhalation toxicity. The right answer would be in the green text, that is uses multiple dose level, that is control, low dose, mid dose, high dose, and this is applicable to typical 28-day repeat dose inhalation toxicology or 90-day inhalation repeat dose toxicology. Okay, and repeated exposure to define both potency as well as target organ. Generally, from this repeat dose toxicology studies only, you will be identifying target organs. Okay, you can pause and go through the why the other options are very not applicable to inhalation toxicity testing. Follow a wide variety of testing procedure which makes comparison of data very difficult. Uses short-term exposure of high concentration to define target organs. This is not this should be applicable to acute toxicology. Considers responses quantitatively interchangeably following exposure to gases, aerosols, mixtures of gases and aerosols. This is not quantitatively. Testing of relatively insoluble particles produces few, if any, effects on the toxicological significance. Coming to solubility, insolubility, first slide we have seen. Okay, this is another very interesting I have found. We'll see first what is the explanation which is given by the previous ABT students, toxicologists. So I would request you go back and check Principles of Toxicology Hayes. In addition to Clayson textbook, you can also read Hayes Principles of Toxicology. Which version I am not aware. And short-term test is for labeling purpose you can use, and for subchronic repetitive and exposure test. The main objective of doing this repeat dose toxicology inhalation studies is to identify NOEL and to identify the target organ toxicity. Okay. See, this is one thing that you have to see. This is the typical respiratory tract. In the case of rat, no, the branching is monopodial, whereas in the case of human, the branching is dichotomous. So this is something new I also learned. So I would request you also to go in deep and understand why, because this is only going to define where the particle will go and deposit. Okay. Now we'll see some of the important list of toxicology tests as per OECD guideline, because the third question was related to inhalation toxicology, that is repeat dose inhalation toxicology study. So similar to that of oral toxicology studies, we have OECD guideline 420, 423 and 425. Okay, acute toxic class method and acute inhalation toxic and fixed concentration method, FDB method will be there, up and down procedure will be there. So here in the case of inhalation, we have OECD guideline 403, which is acute inhalation toxicity. Then we have acute toxic class method, that is the OECD guideline 436, and fixed concentration procedure, that is FDP or FCP, that is OECD guideline 433. And coming to repeat dose toxicology, you have to remember OECD guideline 412, which is for 28-day tox study, and 430 for 90-day tox study. So important features that with respect to each guideline will very quickly go through. OECD guideline 403, it is designed to evaluate the toxicity and potential lethality. So majority of the time, this acute toxicology study, the objective is to identify LD50 or LC50 in the case of inhalation, whereas in the case of repeat dose toxicology, the objective will be to identify novel and target organ toxicity of a substance after a single continuous exposure, typically over 4 hours. Okay. Coming to 436, acute toxicity testing method that uses a step-by procedure. Okay. We are not dosing all the animals at a time with a single dose. This is a decision tree will be there. Okay. You are either increasing the dose or decreasing the dose based on the survival of the animals. Okay. Out of 3 animals. So all animals will not be dosed immediately with a single dose. So using a step-by procedure, I would ask you to go back and check the decision tree will be there. That stepwise decision tree will be there towards the annexure or appendix to determine the toxicity of a substance with few animals. Then OECD guideline 403, animal to minimize animal suffering while maintaining scientific rigor. So what is the thing is that why we already 403 guideline is there. Again we are going for another refinement of the guideline is this the 436, if you see, no, it is in line with 3R principles. So whatever the new ICH guidelines, if there is any revisions or there is any upgrade in the OECD guidelines also, the main purpose is that we have to be in alignment 3R principle. We have to make sure how we can, the existing process, how we can refine it so that we can decrease the number of animals for toxicology testing, not compromising science. We have to achieve the objectives, but we have to take care of the animals also, not subjecting them to too much pain and using less number of animals and gathering maximum amount of data. Okay. Then coming to fixed concentration procedure, acute test to assess inhalation toxicity that does not rely on animal mortality. Here what we are doing, we are not trying to kill the animal, but I think we will pushing the animal towards morbidity or the severe toxicity as the primary endpoint, using fixed concentration to observe the distinctive toxic effects. So this is very important. I will request you to go back, take the PDF, download it, read it in detail, at least tables you try to read. What is the scope, what is the objective, what are the test animal, what are the test species, what is the treatment duration. Okay. Coming to repeat dose toxicology, we have 28-day tox study, that is OECD guideline 412, evaluates adverse health effects resulting from repeated daily exposure. Usually the exposure is 6 hours per day, 5 days per week and 28 days with continuous dosing. So when you are calculating permitted daily exposure, no, what you will be doing, you will be doing correction. 6 hours exposure you have to extrapolate to 24 hours, and 5 days per week you have to extrapolate to 7 days. So 5 by 7, 6 by 24. In certain studies you might get 5 hours or certain places 8 hours, then you have to 8 by 24 or 5 by 24 based on the study details. Coming back to 90-day inhalation, characterizes cumulative and prolonged toxic effects. The whole purpose of going for a chronic study is to identify whether this drug is causing any cumulative toxicity. Okay, repeated daily inhalation exposure for a period of 90 days, providing robust data for quantitative risk assessment. So whenever we are calculating PD or some HBL value, we want to have a chronic study so that because this data will be extrapolated to human, and human life will be around 60 to 70 years will be there. So we can't take a acute study or short term study and extrapolate it to HBL for human. Okay, so pause here. You can see how the whole body exposure is there, how nose only exposure is there. When we are going for whole body exposure, what is the preferable is nose only exposure. For agrochemicals, what we are using. For occupational exposure type of calculation, what type of exposure is there. So this thing you have to remember. See, there are different types of toxicologists available. If you see in the industry, inhalation toxicologist will have himself has have a big challenge because he has to standardize the equipment. He has to make sure that the particles are average size particles are there, cascading pattern. So many challenges will be there for the inhalation toxicologist. If you get an opportunity in your career, try to work with a study director who is working on inhalation toxicology. It's a very good platform to learn. Okay, not each one of us get an opportunity to be a inhalation study director. Okay, next very quickly we'll go through what are the duration. We have seen in the case of acute studies it is 4 hours, whereas in the repeated studies it is 6 hours per day, 5 days per week, like that. Certain times you will come across 6 days per week also. Exposure modes that we have seen, nose only as well as head only. So as I told you, which type of chemicals need which type of exposure. That is generally regulatory prefers nose only exposure because we do not want the particles to be on the fur and the animal is licking that. So all those things we do not want. Okay. Then coming to atmospheric generation, this is again very important. Very big challenge, as I told you, for the inhalation study director. You should be knowing what is MMAD and what is GSD. So please pause the video and go through the definition. And test atmosphere must be carefully generated and continuously monitored. The concentration of the airborne particle should not fluctuate more than plus or minus 10% of the gases or vapors and plus or minus 20% in the case of aerosols. As I told you, mist is there, vapor is there, gases is there, different nature of this inhalation exposure, the particle nature will be there. So that is a very great challenge for the study director. Particle size, to ensure the substance reaches the lower respiratory tract. Our first question was that only, which region? Okay, mass median aromatic diameter for aerosols should ideally between 1 micron to MMAD should be 1 to 4 micrometer. Okay, and with a geometric standard deviation, that is GST, between 1.5 to 3.0. This you have to remember. There is nothing to you have to remember it. And MMAD is median size particle based on mass measurement relative to the unit density sphere. And coming to geometric, this one, relative dispersion of this MMAD such that a value approaching 1 indicates a monodispersed. Whatever the atmosphere in which the animal is exposed, that should be monodispersed. Air should be there. The particles, the concentration of that particular chemical should be monodispersed. Okay, it should not be that only in the corners it is the test item is concentrated, towards the nozzle it is more concentrated, like that. Okay, we'll discuss some other video. We'll discuss in detail inhalation, how to do inhalation toxicology, because it's a very big topic by itself. Okay, so now in addition to that, I would request you, whenever you are reading, no, as I told, please go through the tables. So in this they have given Clayson 9th edition page number 795. They have given figure 15.51 based on the particle size. See which particle size, is it exothoracic, whether it is bronchial, whether it is alveolar, which region it is going. See, fractional deposition of the inhaled particles is the bronchial and alveolar ranges of human respiratory tract. This is very, very important. How this particle size is going to impact which region of respiratory tract these particles are going and binding. And also, I would request you pause and go through this one. Because this concept you'll come across in nanoparticles also, how the particles, once their droplets are there in the atmosphere, how they agglomerate, how the particle size increase. If there is an increase in the particle size, the area of the respiratory tract where they go and deposit, that is also going to change. So particle diameter, accumulation, This alkane and droplet, you see nucleation, conglomeration or aggregation, condensation, these things are very, very important. See here, they have given ultra fine nanoparticles also. As I told you, same concept you will see in the nanoparticle chapter also. Towards the end of Clayson textbook, one chapter will be there, nanoparticle toxicology. Also, please see, as I told you, no, mechanism, which type of flow of this, whether it is impaction, whether it is interception, whether it is sedimentation or diffusion, these things are also very, very important. Okay, so pause here, read this one, or else you go back here to your textbook and read this one. Okay, thank you so much. Be curious. For any questions, you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.